Welcome to Algebra. This begins a series of lessons for a first year of algebra study, going over the basic topics you can expect to encounter over the year. We will begin with an algebra skills review to recall and refresh previously learned pre-algebra concepts and skills. We begin with a review of what you may remember about math. You already should know some basics of math skills used in algebra, generally called pre-algebra skills. What skills or concepts can you remember knowing and using from your previous math learning? Take a moment, pause the video, and write down as many math-related skills you can remember knowing that you think might be considered pre-algebra skills. Here we see a definition found online describing pre-algebra as a middle school course which all of you have just completed, preparing you for the study of algebra, which you are starting now. Take a moment to read through this brief definition. The subjects taught in a pre-algebra course include review of natural number arithmetic, types of numbers such as integers, fractions, decimals, and negative numbers, ratios and percents, factorization of natural numbers, properties of operations, such as the associative property and the distributive property, simple integer roots and powers, rules of evaluating expressions, such as operator precedence and use of parentheses using PEMDAS, basics of equations, including rules for manipulation of equations, understanding variable manipulation, using the four-quadrant Cartesian coordinate plane, powers in scientific notation, probability, square roots, Pythagorean theorem, study of geometry, especially to further the understanding of algebra in applications to area and volume. You may also be studying some statistics and probability. You will use algebra throughout the rest of your math study, including geometry, Algebra 2, and if you go into pre-calculus and calculus and even into college study. Algebra is the foundation of advanced mathematics. Expressions and substitution are two important concepts we will now review in this first unit. You will evaluate expressions using substitution in many mathematical situations throughout the year. Here is an example of a star question where substitution is used to evaluate a function. Let's take a look. We have f of x, which is how you say that, equals 7 minus 4x. This is a function. The question says, what is the value of f of negative 5? And so we replace f of x equals 7 minus 4x. We substitute the x with a negative 5. And now we have f of negative 5 is equal to 7 minus 4 times negative 5. You substitute, or you replace, the x with negative 5. This is now worked out to be 7 minus negative 20. We evaluate this expression, and remember, double negative becomes double positive, and then the final answer is 27. You will also use substitution when checking solutions. We'll do that in Unit 2. Substitution is also used when checking for zeros of a quadratic equation in Unit 9. For solving systems of equations in Unit 5. All these examples will be covered at some point during the year. This lesson focuses on the basics of evaluating an expression when given a value for a variable. So we have an expression versus equation. What do those two things mean? Take a moment, stop the video, and see if you can remember what is the difference between an expression and an equation, and what are the things that are the same and different. All right, let's give it a try. Both contain terms, combinations of letters, variables, and values, with math operations such as multiplication, division, addition, and subtraction. An expression contains one or more terms, usually with variables, and does not contain an equal sign. An equation is two expressions separated by an equal sign. Let's look at some examples of expressions. Here is x. X is a variable. It is a term. It is an expression. 2x, also a term, also an expression. 5. 5 is a term. 5 is an expression. It is also referred to as a constant. 2x minus 5 is an expression. 3y plus 2x and 5x squared minus 6. These are all examples of expressions. Notice there is no equal sign. Note, when a term contains a value and a variable together, such as 2x, this means multiplication, 2 times x, whatever that value is. Let's look at some examples of equations. Here you can see an equation, 2x minus 3 equals 12. It's two expressions separated by an equal sign. Here we have x over 4, which is division, plus 6 equals 8. Here is 3x equals 5x minus 4. Here is 2x plus 3 equals 4x plus 5. All of these are examples of equations. Substitution is used when variables are replaced by values. If we use the substitution property with a variable a as 5 and b as 3, what is the value of 5a plus 10? Well, we replace the a with the 5, so we get 5 times 5 plus 10, and work it out to be 25 plus 10, or 35. 2b minus a becomes 2 times 3 minus 5, which becomes 6 minus 5, which is 1. What does it mean to evaluate an expression? It means to substitute or replace the variables with their given values, and then work out the final value of the expression. When substituting, put parentheses around the number being used to substitute the variable. This is particularly important when substituting with a negative value. Example, if a is 5 and b is negative 3, we evaluate the expression ab, which means a times b. It would be 5 and then parentheses negative 3. Now the parentheses can go around either one of them or both of them. Usually we just put it around one of them. Now without parentheses, it would look very confusing, like 5 negative 3. It almost looks like 5 minus 3. The parentheses is very important to keep this clear. This becomes 5 times negative 3, which is negative 15, which is the final value. Always follow order of operations when you evaluate, also known as PEMDAS or GEMDAS. Here are some examples for you to try. Pause the video, take a moment, and work out these three expressions. Okay, let's check it out. AC plus B, we substitute A with 4, B with 3, and C with 6, and we get 4 times 6 plus 3, which is 24 plus 3, which is 27. B squared plus A becomes 3 squared plus 4. 3 squared is 9. 9 plus 4 is 13. 2A minus C becomes 2 times 4 minus 6, and then 8 minus 6, which is 2. Here's another couple of expressions to try. Pause the video if you need to. Let's work through these. A squared plus 3B becomes 2 squared plus 3 times 5, which becomes 4 plus 15, which is 19. Negative 3a minus 2b squared becomes negative 3 times 2 minus 2 times 5 squared, which is negative 6 minus 2 times 25. Negative 6 minus 50, which becomes negative 56. Now, be careful with PEMDAS, the order of operations. Parentheses, exponents, multiply and divide, add and subtract. It is very important that you follow these as you learn them in your pre-algebra courses. Here's an example. 3 plus parentheses 2 plus 4 divided by 3. What is this equal to? Well, it's important to do the parentheses first, so 2 plus 4 is 6. Then division comes before addition, so 6 divided by 3 is 2, and now 3 plus 2 is 5. Over here we have 5 squared minus 5 over 4 times 2 plus 3. Now there's a big long division bar, and we have an expression on the top and one on the bottom. You simplify the top and the bottom in either order. It doesn't matter which one you do first. So 5 squared minus 5 becomes 25 minus 5. 4 times 2 plus 3 becomes 4 times 5. 25 minus 5 is 20. 4 times 5 is 20. 20 divided by 20 is 1. Watch out carefully for negative numbers. The expression negative 5 squared is the same as negative 1 times 25, the result of 5 squared, and that becomes negative 25. Negative 1 times 5 squared is really a more accurate picture of what this above question looks like. Now, negative 5 in parentheses squared is a little different. It is the same as negative 5 times negative 5, which is positive 25. Carefully notice the difference.